Okay, so we did two examples where we were asked to develop a probability distribution for a variable x. And this is very, very important. Now you have a very powerful tool in your hands if you know how to do that now. Why this? Because the probability distribution can be seen as a representative for the whole population. You see, so when you are looking for any variable, remember we discussed that a lot in our previous classes, that any variable x that has some values, okay, when we list the values of this variable, we are looking at a population of these values, as simple as this. Okay, and when you have a probability distribution, you are able to describe this population, and we're going to see next that we're going to use this distribution to find the parameters, some parameters of the population, which after all, this is the ultimate objective of managerial statistics or statistics in general, right, is to explain a certain population, and we explain it through its parameters. Okay. So let's see how we can use a probability distribution to find parameters of the population, like the mean and the variance. First, the population mean, we can get it, or we can describe it as being the weighted average of all its values. Okay. What's a weighted average? I'm sure that you are familiar with the simple average, where, for example, if you have a variable x that have two values, or it can have only two values, 2 and 4. Now, what's the average here? It's 3, right? How we get it? It's 2 plus 4 divided by 2. So, in other words, what we were doing, we were giving the same weight of 1 over 2 or 0.5 for each of these two possible values. So in fact, even the simple average is nothing but a weighted average where all the weights are equal. All right. Now, what if I told you that these two values happened, let's say I made 100 observations, okay? And I observed that the variable x has a value of 2 in 20 of these, and in 80 observations it has a value of 4. So now, what would be the average? Okay, the average would be 20 times 2 plus 4 times 80, and we divide by 100, right? Because we had 100 observations. So it's like we are adding up the value 2 20 times, because it's repeating 20 times, and we are adding the value 4 80 times, because this is repeating 80 times, and we divide by 100, okay, as we do in any simple average. Okay. Now, instead of these observations, when we have the probability, which is nothing but what? But the relative frequency, which comes from the observation divided by the total. So, in this case, in this example, the value of 2 has a probability of 0.2, and the value of 4 has a probability of 0.8. So the weighted average is what? It's 0.2 times 2, or sorry, yes, 0.2 times 2 plus 0.8 times 4, which is similar to what we did before. And that's why when we are given the probability distribution of variable x, now we can get the mean using this equation, okay, where the mean is a weighted average where the weight of every value is nothing but its probability. So that's why we sum up the products of x times p of x, where x is the value and P of X is the probability of all that, of this value. And we do the sum of all the possible values of X, of course, with their associated probabilities. Okay, in a much similar logic, we can also find the variance of X using the probabilities. When we did not have probabilities and we used to deal with a variable X that has different values, remember, how did we find the variance there? We did xi, right, minus mu squared, okay, and we divided by n for a population, so that's mu. Okay, so here, remember in class I asked you what does that represent, and some of you could answer that this is nothing but the average of the square distances of every value of X, or every point from the average mu. That's why we are dividing by n. Now that when the different values of X occur at different rates, which means it has different probabilities of occurrence, instead of using the simple average, we're using the weighted average. You see, so it's exactly the same logic that we have used in the mean in the previous slides. Okay, so this is why whenever we have a probability distribution and we have a probability for every value of X, this is how we find the variance of the population. So it's either we use that if you want to use the columns, or we simply use this equation where we multiply the square of every value by its probability, and then we sum up all these, right? And then we subtract the squared average, which we get as we learned from previous slide. And of course, the standard deviation is very straightforward. All what we do is we square root the variance that we get in either of these two formulas. Okay, so let's do an example 7.3 to implement this equation that we learned on how to find the population parameter from the probability distribution. So here we are, we see below the probability distribution that we did in example 7.1. Remember, we did that together in the previous segment, and we found for every value of X, here we go, these are X. These are the possible values. For every value of X, we have a corresponding probability. Now, notice that I replaced the last category, which was 7 or more, by the value 7. I had to do this assumption because otherwise we could not proceed in calculating the population mean and the variance, because 7 or more is not a value, it's not a specific value, and we need that. All right, so this is our probability distribution, and now we want to find the mean. Okay, remember how to find the mean. It's the weighted average, which we can calculate by multiplying every value of X by the corresponding probability, and then we sum up everything. Now, if we have a table, just add one more column where you multiply X times P of X, and here we go. So for example, the first one, it's 1 times 0.268. The second one is 2 times 0.33. Then 3 times 0.162, and so on. And since I need the summation of all these, then I add them up, or I sum them up, and we get 2.513. So that's it. This is the mean of the population. Okay. Now, to find the variance, we know that the variance is the summation of x squared times p of x minus mu squared. You may wonder, but we don't have a probability for the x squared. In fact, you're right. We have a probability associated with every value of x. However, when you square every value of x, then the probability associated with this value will be nothing but the probability associated with its squared. So I will add here a column called x squared, and I will simply square the values. So the first one is 1 squared, 2 squared is 4, 3 squared is 9, etc. Now I need to multiply each one of these by p of x. So I'm multiplying by that. Okay, and I will add a column for this. So the first one is 1 times 0.268 is 0.268. Second one is 4 times 0.3333, which will get 1.331, and we do the same for all. Now, in order to get the first part of this equation, what I do the summation here, right? So I sum up this column and I get 8.273. Now here, be careful, many students forget to subtract the average square. Okay, so make sure that you do that step by step. And here we go. So the first part is 8.273, which is the summation, minus the mean that we got on the top, and we square it, right? And we get 1.96. So this is the variance of the population. Now the standard deviation is very straightforward. It's nothing but the square root of sigma, which is sigma squared, which is the variance, and we get 1.4. So that's it. We got now all the parameters that we need for this population.